Welcome to the DIY Honda Garage channel. In this presentation, we will thoroughly discuss DTC P0171, which indicates that the fuel system on the rear bank, also referred to as Bank 1, is operating too lean. A lean fuel condition means that there is an insufficient amount of fuel for the air in the combustion chamber, leading to potential engine performance issues, including misfires and higher emissions. This condition can be diagnosed in vehicles like the Honda Accord V6 from 2008 to 2012, which is equipped with variable cylinder management, VCM. Various components are involved, such as the mass airflow MAF sensor, which measures the amount of air entering the engine, and its failure can lead to incorrect fuel mixture adjustments. Other systems, including the brake booster, PCV, and fuel injectors, may contribute to the lean condition, making this diagnosis critical for optimal vehicle performance. DTC P0171 signifies that the rear bank B1 fuel system is too lean. The term lean here indicates a higher ratio of air to fuel, meaning there's not enough fuel for the amount of air being drawn into the engine. The primary component affected is the mass airflow MAF sensor, which is located in the intake duct just before the throttle body and measures the volume and density of incoming air. If the MAF sensor fails, or if there is debris affecting its performance, it can lead to incorrect readings that adjust the fuel mixture improperly. Other critical components include fuel injectors, which deliver fuel to the engine, and various vacuum hoses and sensors involved in the fuel delivery process. Understanding the roles and locations of these components is essential for effectively diagnosing and resolving the DTC. The possible causes for DTC P0171 include various issues that disrupt the proper fuel-air ratio. One such cause is debris in the mass airflow MAF sensor, which can affect the sensor's ability to provide accurate measurements, potentially causing the engine to run lean. Additionally, disconnected or damaged vacuum hoses can introduce excess air into the intake manifold, which interferes with the air-fuel mixture and leads to a lean condition. Manifold absolute pressure MAP sensor failures could also contribute to this issue, as they provide essential feedback to the engine control module, ECM, for fuel regulation. Other potential causes include defective fuel injectors, a failing fuel pump, or issues within the evaporative emission system. Identifying the root cause from these possibilities is necessary for an effective repair. Common symptoms associated with DTC P0171 include the illumination of the check engine light on the dashboard. This light serves as an indicator that the vehicle's onboard diagnostic system has detected an issue that requires attention. Along with the warning light, drivers may notice poor engine performance, including hesitation during acceleration, rough idling, or loss of power. A lean condition often leads to combustion inefficiencies, which can manifest as increased emissions, potentially causing the vehicle to fail an emissions test. In some cases, the engine may also produce an unusual noise, indicating that it is struggling to operate normally. Recognizing these symptoms early can prevent further damage and more extensive repairs. The first troubleshooting step involves a failure confirmation test while the engine is idling. Start the engine and allow it to idle in park or neutral without any load. Utilizing the Honda Diagnostic System, HDS, monitor short-term fuel trim, STEP fuel trim values for both banks, B1 and B2. If either value reads 1.15 or more during this idle condition, it indicates that the system is running too lean, requiring further investigation in the next steps. Conversely, if both readings are within acceptable limits, this suggests the fuel trim levels are normal, directing you to proceed to the next diagnostic step. Accurate monitoring of fuel trim values is crucial, as they play a significant role in assessing the fuel delivery efficiency of the engine. In the second troubleshooting step, you need to review the onboard snapshot data recorded during the first step. This snapshot is essential as it reflects the engine's operational parameters when the fuel trim values were at their peak. Specific values to document include engine speed, vehicle speed sensor, VSS, relative throttle position, TP sensor, and accelerator pedal position, APP sensor. After noting these values, drive the vehicle while recreating the conditions under which the snapshot was taken. Check again whether ST fuel trim B1 or B2 reads 1.15 or more during this test. If they do, it confirms that a high fuel trim value persists under these conditions. If not, it indicates that the system is currently functioning normally. For the third troubleshooting step, proceed by removing the MAF sensor for a closer inspection. This sensor plays a pivotal role in determining the proper fuel-to-air ratio, and any blockage or debris could lead to incorrect readings. After removing the sensor, check for accumulation of foreign objects, such as lint, insects, or dirt that may inhibit its performance. If debris is found, it's necessary to remove it carefully. Afterward, use a vacuum cleaner to eliminate any remaining contaminants within the air cleaner housing. If the sensor is clean, reinstall it and move on to the next troubleshooting step. Ensuring the MAF sensor is free from obstructions is essential for accurate operation. The fourth step involves a visual inspection of critical components related to the intake and fuel system. Check each of the following parts: the crankcase breather hose, intake air duct, oil cap and dipstick, and the air cleaner housing. Look for any signs of disconnections, cracks, or damage that could allow unmetered air to enter the intake system. If any components are found to be compromised, they must be repaired or replaced as needed. A thorough inspection helps ensure that all connections are intact and that the fuel system functions effectively without unnecessary air leaks, which could cause a lean condition. Proceeding to step 5. Continue to let the engine idle while pinching the brake booster vacuum hose, which connects to the intake manifold. This action temporarily isolates the brake booster system, allowing you to monitor its effect on the fuel trim values. While pinching the hose, observe ST fuel trim B1 or B2. If either still reads 1.15 or higher, it indicates that the brake booster and its hoses are not the source of the vacuum leak. However, if the fuel trim readings drop back to normal levels, it confirms a leak exists in the brake booster system or its hoses, which should then be investigated and repaired. This step helps isolate the cause of the lean condition effectively. In the sixth step, continue letting the engine idle and pinch the positive crankcase ventilation (PCV) vacuum hose connecting to the intake manifold. This test helps to further verify if the PCV system is contributing to the lean condition. As with the previous step, monitor ST fuel trim B1 or B2 while the hose is pinched. If the values remain 1.15 or higher, it indicates a functioning PCV system with no leaks. Conversely, if the readings fall within normal limits, it suggests a leak is present within the PCV system, requiring closer inspection and potential repairs of any damaged hoses. This isolation technique is crucial to accurately diagnosing the source of the issue. In this seventh troubleshooting step, the focus remains on isolating potential sources of vacuum leaks. You will pinch the vacuum hose connected to the evap canister purge valve while allowing the engine to idle. This action helps determine if there are leaks in the evap system affecting the fuel trim readings. While the hose is pinched, closely observe ST fuel trim B1 or B2. Should the values remain elevated at 1.15 or higher, it indicates that the evap canister purge valve and associated hoses are functioning correctly. If the readings drop, this suggests a leak in the evap system that must be identified and repaired promptly. Identifying the integrity of the evap system is vital in resolving issues related to fuel system performance. The 8th troubleshooting step involves holding the engine speed at approximately 3,000 RPM until the radiator fan activates. It is critical during this phase to ensure that necessary conditions are met, including having the engine coolant temperature (ECT) sensor above 158 degrees Fahrenheit, 70 degrees Celsius, and all electrical loads turned off. Using the Honda Diagnostic System HDS, monitor the MAF sensor readings at this RPM. Each specific model has predefined MAF sensor specifications to compare against, such as 9.1 to 12.9 grams per second, GMs per second, for certain Accord models with VCM. If the MAF sensor readings are within these specifications, the sensor operates correctly. If not, further investigations, such as inspecting for a damaged air cleaner assembly or potentially replacing the MAF IAT sensor, may be necessary. Step 9 involves checking the fuel pressure under the same circumstances when ST fuel trim B1 or B2 was found to be elevated. Accurate fuel pressure is essential for the proper functioning of fuel injectors, and varying from the expected range can significantly disrupt engine operation. Specific models and their corresponding fuel pressure specifications must be referenced, such as 57 to 64 psi for certain Accord V6 models. If the fuel pressure is found to be within the acceptable limits, it confirms that the fuel system is functioning correctly. If the fuel pressure is low or high, replacing the fuel tank unit may be mandated, as inadequate fuel pressure can directly contribute to a lean condition that prompted the DTC. The 10th step involves checking for vacuum leaks in the intake manifold, a major contributor to lean fuel conditions. Disconnect the intake air duct from the air cleaner housing and utilize the OTC Leak Master smoke machine to introduce smoke into the intake manifold. As the smoke travels through the system, any leaks will be visible, proving critical in pinpointing the failure. Inspect every joining point, including the intake manifold gaskets, throttle body gaskets, EGR valve connections, and vacuum hoses. If there's a notable leak, it should be repaired to restore appropriate vacuum levels. This examination serves as a pivotal point in diagnosing the lean condition linked to DTC P0171. In the 11th troubleshooting step, the focus shifts to the fuel injectors, which are responsible for delivering fuel into the combustion chamber. It's essential to replace the existing fuel injectors with known good injectors and then operate the vehicle under the previous conditions where stent fuel trim B1 or B2 was problematic. If the stent fuel trim values remain elevated, this indicates the injectors were not the source of the lean condition, prompting further investigation in the next step. However, if the values fall within acceptable parameters, it affirms that the fuel injectors were indeed at fault, confirming their crucial role in achieving the appropriate air-fuel ratio needed for combustion efficiency. Step 12 involves replacing the air-fuel sensors with known good sensors. This is vital as these sensors provide essential feedback to the engine control module for adjusting the fuel-air mixture accurately. After the replacement, drive the vehicle under the same conditions as before to see if ST fuel trim B1 or B2 continues to read 1.15 or more. If the values do not drop after installation, this indicates that the air fuel sensors were not responsible for the high readings. Conversely, If they do fall within the normal range, it confirms that the sensor change effectively corrected the lean condition associated with DTC P0171. In the 13th step, the focus is on potential fuel-related issues that could cause the lean condition. If the misfire occurred shortly after refueling, it's vital to remove the fuel tank unit to drain and refill it with known good fuel. The quality of fuel significantly impacts engine performance. Therefore, ensuring only high-quality fuel is used is imperative. After replacing the fuel, operate the vehicle again under similar conditions. If the ST fuel trim B1 or B2 values persist at 1.15 or higher, the issue likely lies elsewhere, such as possibly requiring a known good engine control module, ECM, to investigate further. Conversely, if the problem resolves, it validates that bad fuel was the triggering factor for the lean condition. The final step involves confirming the repair. Start by turning the ignition switch to the on position and reset the engine control module, ECM, or powertrain control module, PCM, using the Honda Diagnostic System, HDS. Following the reset, perform the idle learn procedure, which allows the ECM-PCM to recalibrate the engine's idle speed in the absence of load. After completing these tasks, start the engine and monitor stand fuel trim B1 or B2 once again, while holding the engine speed at approximately 3,000 RPM until the radiator fan cycles. If both stand fuel trim values are now normal, the system has returned to its expected operational parameters, confirming a successful resolution to the DTC P0171. To verify the success of your repair related to DTC P0171, conduct a comprehensive review of the vehicle's operational status. Check to ensure that the previously activated check engine light has turned off and there are no active or pending diagnostic trouble codes. After confirming the operational integrity of the repair, don't forget to reset any maintenance indicators that may have been triggered during your diagnostic process. A thorough examination and validation of repaired parts should be conducted to ensure overall vehicle health. This follow-up step is invaluable in maintaining ongoing vehicle performance and reliability, allowing the driver to have confidence in their vehicle's fuel system. Preventive maintenance plays an essential role in avoiding the complications associated with DTC P0171 in the future. Regular inspection of the mass airflow (MAF) sensor is crucial. Ensure it's clean and free from debris to allow for accurate readings. Keeping an eye on vacuum hoses for any signs of wear, cracks, or disconnections can save you from unexpected issues later on. Furthermore, using high-quality fuel consistently aids in maintaining optimal engine performance and efficiency. These preventive measures not only enhance the longevity of the vehicle, but also ensure peak functionality of the engine and fuel systems, promoting better fuel economy and lower emissions. In conclusion, diagnosing DTC P0171 is a multifaceted process aimed at identifying the root causes of a lean condition in the rear bank fuel system. Throughout the troubleshooting steps outlined, we learned the importance of precise monitoring and diagnosis of various components such as the MAF sensor, fuel injectors, and vacuum systems. Each step provides insights into how maintenance and timely repairs significantly contribute to the overall health of the vehicle's engine performance. Additionally, integrating preventive maintenance routines ensures longevity and reliability, minimizing the risk of recurring issues. A comprehensive understanding of this diagnostic process empowers technicians to effectively resolve fuel system issues, leading to an enhanced driving experience. Please like and subscribe to the channel. See you next time.